But for whatever that's worth, if you want a way to increase your grades, that's money. My daughter does it. She has straight A's going right now in college in a very tough schedule. My son's got straight A's in actuarial science, which is one of the harder majors there. That and probably chemical engineering. They're the two that are the most daunting. Maybe architecture in terms of time that it sucks away from you. But anyway, whatever. Questions on the review?
It's not about the review.
Questions on anything?
Okay, so how do you find the y-intercept of the slant asymptote? Because isn't it like different than the intercept of the graph?
Yes.
How?
So the y-intercept of the slant asymptote, it's whatever you get when you divide. So like if I had a slant asymptote, it might be a situation like...
oh, I just didn't divide. I think that's the problem.
If you don't divide completely, yeah. Like if I have something like this, you know, and I go, oh, power's bigger on the top, I must have a slant asymptote. So if that was the case, I would just divide that -4 in here. Now it's easy to just eyeball it and go, hey, when I divide, I'm going to get a 2x.
Yeah, I just found the slope.
Yeah, that would just give you the slope, but you don't know where it is. So you would actually have to, it sounds like you get it, but in case you don't, somebody else doesn't. So you can see the slope's going to be 2, but when you actually finish the math out, you go, oh, 2x minus 11. But yeah, don't confuse that y-intercept with the actual y-intercept of the graph. Because this is the y-intercept of the slant. Which the graph, remember, the graph is going to follow the slant out to infinity. Is the graph going to necessarily follow that slant up in the belly of the graph? No. Right? You know what I mean? When you look at these pictures and you see all the verticals and all the swooshes and all that junk, you don't look at that and think, oh, line. Right? But it looks like a line as you go out forever. So as the closer you get into the guts of the graph, that slant or that horizontal is doing very little. It isn't. And you can cross those. Somebody mentioned that 7th period. They asked about that. You learned probably in Miss Tyree's class or somewhere along the line that you couldn't cross vertical asymptotes. But when you learned that, you didn't know about slants and horizontals. So in your head, you remember, I can't cross asymptotes. That part's not true. Okay? You can cross asymptotes. You can cross slants and horizontals. You just can't cross verticals because at verticals, the graph is what? Undefined. But at the other ones, it's not undefined, right? So get that straight, because I have a lot of people going like I can just see them when they're graphing something, like they'll set it up, you know, and they'll have their verticals in there, and they'll have their slant in there, and they're like, okay, I'm going, whoa, and they just stop. It's like, I can't cross. But yeah, you can cross that right, or not right there actually. They'll get right here and they'll go, oh, wait a minute, I can't cross. What do I do? And they freeze. You can cross slants. I mean, it's totally possible to cross them. Okay? So you very well may, but remember, you just can't cross a vertical like that. And more than likely, as you head out to this slant, you probably are going to just stay on one side of it. Same thing with horizontals. You're probably not going to cross it a bunch, even though you might cross it somewhere. It's possible. But that would always usually occur here in the belly of the graph as opposed to the extremes. What else? Anything on the review? And if you don't have questions, then you should be just working on the review right now. Because this is like a typical review day. Just people at home. I'm trying to put something on film for them if they have a question. Yes?
Is the intercept on the graph up there at 1 and 4? Are those like triple roots? Okay,
4 would be a triple. Let me get rid of this and move it up. Yeah, and I'll give you but these are really hard to make. I draw them sometimes, but they're really hard to make without, like sometimes you're like if I were to zoom in on this, I would see it a lot better, you know? But then this thing would be way down. On this graph, I think this is actually something like 20,000. I put the tick mark so it looks like -1, -2, -3, -4, but it's so far down, but it's so hard to make these where they actually look decent. But yes, this would be a triple. Can everybody see this? And then it looks like I'm going down and then crossing at 2, so that's a single. But then it comes up over the graph and then bounces at 1, so that's a double. And then it looks like there's a wiggle right here, so that's 2 imaginaries. And then there's a single and there's a single. Now I will make mine more clear. Like I have a family of these that I save. And sometimes I use the crappier ones on the review sheet where it won't cost you and you maybe ask a question. And I put the ones that are a little more clear on the test. And this would have a min, and what's the min? I know you can't actually give me the value, but assuming this was like -1, -2, -3, -4, what would the min be?
Y equals -4.
Yeah, and you don't even have to say y equals. I know it is a y value, but it's assumed that, so just say -4. Based on assuming these are 1 unit tick marks. And then what would this be right here? A relative min, and it would be, I don't know, -0.6 maybe, -0.5, whatever. And what would this be right here if this is a little dip? That'd be another relative min, right? Maybe a relative min at 0, because it bounced right there. Because remember, relative min has to go decreasing, then increasing. So, decreasing, increasing, relative min. Also, min. Right here. This one, it's kind of hard to see if it actually went increasing. It might have just flattened out. So it's really hard to tell. You would have to maybe get your calculator out and really see if it dipped. But again, I don't give problems like that I'm unsure of. I make them pretty clear on a test so there won't be debate about that. And then does this have a max? No, the max doesn't exist because it goes up forever. Don't say infinity, remember? And then what would this be that I'm pointing at? A relative max, so the y value may be 0.7. And then what would this there's a little hill right here in between where it bounces at 1 and where it crosses at 2. That would be another little rise, fall, right? Increasing, decreasing. Another relative, I don't know what it'd be, 0.1 maybe. And then that looks like it. As far as that's concerned. Are y'all good with your calculators? I'll tell you what you need to know. You got to be able to take a graph like you see in number 2, and you should be able to look at it and tell me what the left-right behavior is. Can you do that? Just eyeballing it right now? Up to the right, up to the left. Why is it up to the right? Because it's what? Up to the right because it's positive. And it's up to the left because even says what? Even powers say what? Same direction. So it's up to the right because it's a positive 2, and then the 4 just says same direction. But if you graph that, you'd see that. And you should be able to graph this and be able to determine the max, the min, zeros, intervals where it's going up, intervals where it's going down or decreasing, increasing or decreasing, relative maxes and relative mins. But I'm not going to make you do all of them. I'll probably say, hey, give me one of the roots or one of the zeros. I might say, give me the min. And you got to give it to me. I'll probably do that. I'm not going to ask you a million questions. I just want to make sure you can put it in your calculator and find a couple things just to show me. And by the way, guys, it's so easy to put these in your calculator incorrectly. Every year I see somebody type this in. They go f1 of x, and they go in there and they go 2x to the 4th minus x cubed minus 20x squared, and they forget to bring it down. And it's all stuck up there in the exponent. Here's another thing I see. You know how there's a difference between your minus and your negative? I see this all the time. They'll hit the negative sign, which is a little bitty tiny minus, and guess what the calculator does? It thinks it's times a negative. So it ends up graphing the negative 2x to the 7th graph, which looks totally different. But can I tell what you have in your calculator? I have no idea. So it ends up, you end up missing everything. Be really careful on these calculators. And it's like that on the AP test too. You type it in wrong, you're going to miss it. And nobody can see your work. There's no partial credit. So double and triple check and make sure you have the right powers on there. Make sure you don't forget a term. I know I do it occasionally. And I've done this for a zillion years. So double check your work on these calculator problems. Now I will say this, if you did miss it, and you came back to me later and you went, Mr. Hurry, check this out. I know I missed these, but I can show you exactly why I got this answer. If it was still in there, you know what I mean? If it was still in there, I could look at it and go, okay, I'm going to still count off for you not knowing how to use your calculator, but I will find a way to kind of think through it and give you credit for at least finding the problem right based on your bad equation. But the second you erase it, which very well might happen on a different problem, it's gone forever.
Why is there a multiplication?
I was saying that if you this is wrong. I'm saying if you accidentally hit the negative sign instead of the minus,
Okay.
your calculator goes boop, and changes it to times a negative.
Okay.
So you got to be careful. You don't want that to happen. So make sure you hit the minus. The minus sign looks bigger than the little negative sign, and you should never have a negative unless you're leading with it. I got to be honest with you. I don't know why they did that. I don't know why they just can't make the calculator smart enough to know that a minus out front is a negative and then just have one thing on there. I mean, it does everything under the sun. How come you can't do that? Whatever. There must be a reason. There's smart people making these things. Seems dumb to me. What else? Anybody just scrolling through here? Anybody? What should you see about number 14? What should jump out at you right there? I'm giving you the picture. What am I giving you? I'm giving you a picture that guides you towards your guesses of your roots, right? Now this one wouldn't have been that bad because it only has plus or minus 1, plus or minus 3 over 1. But what if that was a 30? That's a lot of guesses for you, right? But by giving you the picture, I'm telling you, oh, not only does it touch at negative 1 and 1, so I'm giving you 2 of the roots, but also what?
It's a double root.
It's a double root. So I'm giving you negative 1, and 1. That's 3 of the roots. Don't just write 3 of them down and go, oh, well, I got 3 of the 5. Don't do that. You're going to get slash dotted for that. What are you going to do with those 3? Do what? Use them to synthetically divide and shrink that sucker down to x squared, and then you can find the last 2. Y'all remember Descartes' rule? When is it really going to end up being helpful to you? Alternating signs or? Same. And remember, the alternating can be a little off because the alternating only is going to help you if there are no missing powers. 5, 4, 3, 2, 1. If they alternate and there's a missing power, then they really didn't alternate. And you'll think that's helpful, but it really probably isn't. But if you have every power, all the way down from the lead, all the way to the constant, then yes, alternating, all the same. All the same always helps. Okay? Because all the same is going to give you no positive roots. That's helpful, all right? Because there's no changes. Yeah?
How many relative extrema can you have if the polynomial has a degree of n?
Let's think about it. What if it was x squared? Right? X squared, what's the most? I mean, it looks like a parabola, right? So forget that. If it's x squared, the most you can have is 1 min. X cubed. Now we look at x cubed like this, but could it also look like that? So the most you could have is 2. X to the 4th. It could look like a parabola, but it also could look like that, right? Because 4 roots. 1, 2, 3. So if it's that and 3, or that and 2, or that and 1, then it's n minus 1 if it's n. But you know how I got that? I didn't like do any large proof. I just said, well, let me just play around and see. What else, guys? Anything to remember about number 20? When you synthetically divide? Yeah, when you're finished dividing by that negative 1/3 synthetically, you got to go back and divide by a 3. To me, that's worth a slash if you forget that. Okay, because that's what I'm really checking to see if you know here. Do you divide, like when you get to the remainder, let's just say you get to here and your remainder's 5, right? You put 5, do you put 5 over 3x plus 1 and a 3, or just 3x plus 1? Just 3x plus 1, because it's already got the 3 in there. Right? When you're synthetically dividing by that 1/3, that's as if you factored the 3 out. The 1/3 came from that. So this already has the 3 in there, so you don't have to divide it. But every other term, yeah, go back and divide by 3. Y'all remember the factoring we did, the new kind of factoring? If you ever have a factor like this with a plus, what are you going to have to allow that to factor? If it's plus, what are you going to have to make that happen? You're going to have imaginaries. If it's minus and that's not a perfect square, what are you going to have? Roots. What if it's plus and it's not a perfect square? Roots for the 5, but also i's to make sure it ends up being positive. So on something like that, and if you forget this stuff, think about it. If I have x squared plus 9, x squared minus 9, that is x minus root 9, x plus root 9. So x minus 3, x plus 3. This is x minus root 9 I, x plus root 9 I. I need the i's to make the plus. So x minus 3i, x plus 3i. Right? Well, the only difference now is, if it's not a pretty number like 9, it's a 7, you just get that. If it's not a pretty number like 9 and it's a 7, you just get that. But if it's plus, you're going to need an I, minus you don't. If it's not a perfect square, you're going to need a radical as well. And if I need i's, I'm factoring over the what? If I need i's, I'm factoring over the rational numbers? No. What am I factoring over? Complex. Because complex includes everything. It allows i's as well. If I don't need i's, and I can get away with just radicals, then I'm factoring over the what? Reals, because reals include rationals and irrationals. So you brought irrationals in the mix. If I don't need any of that, and I have something like, I don't know, say I had x squared minus 4, x plus 2, x minus 2. I didn't need rationals or imaginaries. Then I'm factoring over the what? Just rationals. That's what we've been doing all along. Rational numbers. But if I have to pull out radicals, then I'm using irrationals as well as rationals. That's real. And if I got to pull out i's, then I'm using reals and imaginaries. That's complex. So that's what I'm asking right here. Y'all tracking with me? Let me show you one other thing. People, for some reason, what if I gave you that and said factor over the rational numbers? Rational means you cannot use what? I's or square roots. I see people do this. They go x squared minus 9, x squared minus 4. Okay. But in their head, they're thinking, oh, rational is just the first step. But can I go further using rational numbers? Then go further. Don't think rational means one step, then real means 2 steps, and complex means 3. Rational means go as far as you can using just rational numbers. And I can go further. I don't have to pull out radicals and junk like that. There are no i's that are needed here. So make sure if it says rational, you go as far as you possibly can using just the rational numbers. And do that with each of these. Don't just memorize stuff. Here's something we actually haven't done this year. Let me find a better one. There's something nastier. Maybe not. I'm going to make one up. Unless y'all have a question.
What's the difference between real and complex?
So complex, remember that big diagram we put up there? Complex is every number on the planet. So that includes reals and imaginaries. So if I say complex, everything's in play. But if I just say real, then I have separated myself from the imaginaries, and it's everything that doesn't have an I. Now it might have radicals in it, like 2 minus root 3, but no i's. A lot of people think when you say complex, you mean imaginary. But that's not true. Complex is everything on the planet. All right, I'm going to give you something here. take me a second. I haven't forgotten you. Okay, I'm going to make a problem. It's probably, arguably, and I hope I don't make a careless error here. That would be very frustrating. But this is probably one of the easier things to do in terms of what you do, but hardest things to do in terms of not making a careless error. Okay, so here we go. Okay, hopefully I didn't make a careless error in making this. Okay, ignore all of this. Just looking for white space here. So what if I gave you this polynomial? And I told you that 2 minus 3i is a root. So what would you do? What do you know and what would you do to solve that thing? Anybody? 'Cause that's a test question. 9 years out of 10. Okay, one option, and this is the way I think that most people do the best with, even though it's the most tedious. And I say that because people tend to not like long division. But one of the ways is to do synthetic division here. Now, what's going to happen? What do you know about imaginary roots? They come in pairs if there's no i's in the problem, which there aren't. So that means I also know that 2 plus 3i is a root. You're not going to get really much, if any, credit for saying, hey, 2 plus 3i is also a root. I found one of them. That's algebra 2. Okay? So you could synthetically divide. But I do know that both of these are roots. So if I start with 2 minus 3i, I want to just point out and remind you how nasty this is going to be. I'm even going to really separate these. Now watch how nasty the math is, but here's the beautiful part. You know if you make an error, because what do I know should happen by the time I get to there? I know I have to get a 0 there. Which also means I know I have to get what here? A negative 65. So if I've done it wrong, if I know this is a root, which I'm praying I didn't multiply wrong. We'll see. But I know that, so I have a check on a test. So let's try it. Drop the 1. That times that. Well, that already looks funny, but I'm trusting the process. Add this, so I can only add the real parts. That times that. Now I stink with that in my head, so I'm going to come out here to the side and FOIL that out. So negative 8, negative 6i, positive 12i, positive 9i squared is negative 9, so negative 17 plus 6i. Please stop me if you see an error. When I add that, I get 9 plus 6i. Well, again, that's terrible, so I am going to multiply that again. And that gives me 18 plus 12i minus 27i minus 18i squared is plus 18. 36 minus 15i. Add this and I get negative 10 minus 15i. Now let me show you how you can make a little check. So I really don't have to do this twice. Now, if I can factor a number out of this, hold on. I know that when I multiply here, I've got to get a whole number. What's the only way to get a whole number if you're multiplying imaginaries? If they're conjugates. So that means this and this has to be a conjugate. Now at first glance they're not, right? But what if I factored out a negative 10 out of this? 2 plus 3, a negative 5 out of this. 2 plus 3i? Do you see that? If that's a conjugate in there, then I've done this right. There's no way you would have had, there's a greater chance of getting struck by lightning twice than making a mistake that would actually give you the wrong answer here, but still be the conjugate of this. It's not going to happen. Okay? I say that, you're going to do it on your test, but it's just not going to happen. So if that happens, you can go, oh, that's a conjugate, negative 65. I would just trust it. But to prove my point, I'll do it up here. 2 minus 3i times negative 10 minus 15i, negative 20, negative 30i, positive 30i, look, that canceled, and positive 45i squared, which is negative 45, and there's my negative 65. So really, if you're doing it this way, you really only going to have to FOIL twice if you check for the conjugate. Now, you think, well, no, you're not, because now you got to do it again. But look, the next time through, so nice. Everything just is going to be beautiful, right? Because if I take one imaginary out, I'm left with a bunch of i's. But if I take both imaginaries out, I'm back to coefficients and constants that are real. So check it out. 1. Multiply. Oh, look at that. Multiply. Negative 4 minus 6i. Oh, look at that. Multiply right here. 10 plus 15i. Oh, look at that. So the last one is super easy. So it's not as bad as you think, but I'm going to show you another way. And then what do you do finally at the end here? Quadratic formula. So quadratic formula complete. Now, I'm going to show you this other method. If you are like, wait a minute, I know how to do this, I'm good, then you can la through this if you want. But I see people all the time, especially people that really are good and consistent and don't tend to make careless errors. Watch this. This is another way to go about it. I'm going to leave that there just a second. What if I did this? Instead of synthetically dividing with these roots, what if I combined these roots back into their original quadratic factor? Now, I can't undo the quadratic formula, but I learned something called the sum and product rule. You learned it last year. If you didn't, here it is again. Or for the first time. I'm pretty sure you learned last year. The sum and product rule says, if I take the sum of these two, 2 plus 3i plus 2 minus 3i, and the sum's easy, and then I take the product's a little bit more complex, but not a lot, right? 4, outside inside cancels, negative 9i squared becomes what? Positive 9, so 13. Take the sum and the product and do this. X squared minus, so change the sign of the sum, put an X on it, plus the product. X squared minus the sum plus the product, and then just take that, which represents these two roots, and divide it in there with long division. Now people hear long division and they go, oh man, long division. Oh, I hate the long division. But look, it's not that bad. Check it out. You know, I should probably not give you brutal long division problems in Algebra 2, because it makes you really afraid of long division. Because when I made you do long division, it was like x to the 12th, you know, and you were dividing in there and it took 10 steps. But right here, it's going to be 3 quick steps. And you're going to get what as a remainder? You know this, because these are both roots. So check it out. That goes into that, x squared. That looks familiar. Change my signs. X squared times what gives me this? Negative 2x. That looks familiar. Got to drop this down. Change my signs. That goes into that how much? That looks familiar. And I know it's going to work if I've done the math right. When I multiply this out, 5x squared minus 20x plus 65. Look, when I subtract this, and then all I have to do is now go solve this. So you got to ask yourself, would you rather do synthetic division twice, or would you rather do the sum and product rule with long division once? Now you look at the math right there, it kind of feels about the same. Most people in my classes, for some reason, like this better. And maybe it's because if you get the sum and product rule wrong, remember the sum and product rule says x squared minus the sum you got times x plus the product. So change the sign of the sum, but don't change the sign of the product. Divide that in long division. But normally there's like a couple people that like this way, and because they're so used to solving this way with every other problem, they kind of like to stick to it. And really, it's only bad twice. You got to FOIL twice to get there and there. And if you recognize that's a conjugate in that last step of this, or a scalar conjugate, it's not as bad maybe as you think initially. What else? My phone is ringing off the hook from the other classes, putting in their questions. Horizontals, verticals, we're all good on this? How about looking at this number 27? How many x-intercepts does 27 have? How many? What's it always a good idea to do first? So that's not an x-intercept or a vertical asymptote, it's a hole. So how many x-intercepts do you have? Or roots do you have? I got one at -2, and I got one at 0. It's a bounce, right? But I have two different places it's going to touch across, and that's definitely a bounce. What kind of do I have a horizontal or a slant up here on 27? Well, I got a slant, don't I? Because this would be a 3x cubed over an x squared, assuming the hole is gone. That's a slant. What about on 28? Slant or horizontal? Horizontal, why? Because it's either equal or greater on the bottom, and since it's greater on the bottom, what would that horizontal be? Not just 0, what would it be? Y equals, because it's line, good. What would you have here on 29? Horizontal, what would it be? Y. Because that's 4x squared over 2x squared. Power's the same, use the coefficients. Have y'all done any of these this week? I forget who I've talked to. It's like having 4 different classes. Have y'all done any of these where I gave you the information? Can I encourage you? You maybe did something like this last year, maybe not. But here's what you know how, I don't know if you've experienced this. Have you done any of these rational functions where maybe you accidentally get the wrong horizontal? And you have everything else right, but because the horizontal's in the wrong place, everything kind of doesn't make sense. Like it just destroys what you're trying to sketch. And your sketch looks totally different because you have a horizontal at y equals 2 instead, or x equals 2 instead of x equals -2. Well, sometimes I'll give you this information, and if you don't read the question, it's going to kill you. So I want you to read this question. It says all of the asymptotes are given. Great. All of the x-intercepts are given. Now what does that mean if I gave you all the x-intercepts? It can't cross anywhere else except what's indicated. Some other points, holes maybe. Sketch the graph, and then look what I give you last. Assume that all the x-intercepts come from odd-powered roots. What does that mean if all the x-intercepts come from odd-powered roots? No, listen. What does it mean if all the x-intercepts? X-intercepts come from the numerator, right? What does that mean if they're all odd-powered roots, which means no like x squareds? No bounces. Now, what if I were to add that and say none of the factors in the problem? Which sometimes I do this on a test. I don't say this, I say it a little bit differently just to see if you're reading. What if I say that none of the factors in the rational function have even powers? Then not only do you have no bounces, but you also don't have any what? Volcanoes. But I didn't say that here, did I? So here you could have a volcano because I just am saying none of the x-intercepts. That's numerators aren't double roots. Make sure you see the difference there. So can you look at this picture based on this information and tell me what the graph looks like? Can I give you a hint on this? If you haven't caught this yet, and I've given this analogy a couple times. If you ever take a multiple choice take a multiple choice test, and you have no idea what the answer is, but you know it's not A, B, or D, so you go, I don't even know what the word C means, but I can argue away A, B, and D, so it must be C. That's how you have to think on these. Like, this would be my thinking. I know that this graph here on number 30 has to follow this slant asymptote. So I know that coming in from this, it's right on that, maybe above, maybe below. And right here, it's right on it, maybe above, maybe below. So tell me, what's going to happen as I come in here from the left? Why? Because for me to go up, I would have to cross again. And I can't because all the x-intercepts were given. So that option doesn't work. So by default, it must go the other way. Why can't I just hit this point and then go through to the next point? Why can't I do this? Why can't I ride up the asymptote, hit this, can't cross the vertical? So basically, all the other options are off the table. So the only option I have is to come up, hit this, and then dive back down. It's something like that. Now, what happens if I come in from the right side? What are my options? Really? Why can I not do this? Oh, x-intercepts come from odd-powered roots. Now, that would totally be possible. People go, you can't cross a slant. Yes, you can. But this is not possible based on these directions. But if I don't put that stuff in parentheses, then this is totally possible. Although, so is this. Now, what happens here? Because this, is there anything keeping it from starting low and coming up and crossing and hitting and coming down? Did I forbid volcanoes? I didn't. Not on this one. I might on your test, but if you don't read, you won't know it. Right? So if I say the x-intercepts, I'm talking about numerator factors, don't all come from odd powers, then there's no bounces, but that doesn't mean there can't be volcanoes. So this one could have gone either way. I think my key probably looks like this, but it could have gone either way. Yeah?
What's the rule when you're synthetically dividing by something like 3x plus 1 at the end?
Yeah, we mentioned that. So if you're dividing by like a 3x plus 1 or anything that has a value other than 1, then when you get your answer and you've got all your numbers, here I'll put 0. You all have all your numbers here, right? And then here's your remainder. So you're just going to put that over 3x plus 1, but everything else has to get divided by that 3. Technically, you always divide by the lead number, but when it's a 1, it doesn't change anything. So if you really wanted to remember, oh, always divide by the lead number, I probably should teach it that way. Then it would be burned in your brain all the time, but it just doesn't matter sometimes. And again, that to me is worth a slash on this problem. And what do you think the biggest mistake in synthetic division is? I can think of 2 other than that. Forgetting the zeros, and then shockingly, guess what the other one is? Not copying the problem down wrong. I did it once in this past 2 weeks. I was like, why isn't this working? And then yesterday, in doing one, I was like, I know this is a root, why isn't this working? Before I could even think of it, I was like, somebody goes, forgot a 0. I mean, it does, it happens to everybody. Especially when you're in the heat of battle, which you will be on Tuesday. Right? So be able to think through these. In fact, let me just give you one. For blank space here. What if I gave you this picture? I get people all the time on this stuff. Sketch the graph. No volcanoes, no bounces. What do you know has to happen as you head to the right here? You got to follow the horizontal, right? So as you're coming in on this horizontal, what are your options? Hit this and go down? Whoa! I gave you all the x-intercepts. So you can't go down. You go down, you just miss that part. What is my only option if you have all the x-intercepts given? To hit this and go up. No place to go down. Now, if there's no volcanoes, what has to happen here? It's got to do that, probably, right? Now, here's the last thing. Am I finished? Actually, if there's no volcanoes, let me take away the no volcano. Because I would have to have a volcano here. Because I can't do this. And for those who are like, how do you even know there's stuff there? I know there's stuff on this side, even though I don't see a point, because what has to happen? I've got to follow the horizontal. It has to do that. So you would have to be coming in and diving down or coming in and diving up. And this one would have to look like this since there's no place to cross. So something like this would have had a volcano. Well, then that would have a volcano. Yeah, oh, yes, yes. Yeah, you could have done this as well. But not both. I think you're with me? All right. Y'all have a good weekend.
You as well.
Will.